All right, so if you could switch your screen over so you can see the meat, that would be great. As I said, this is going to be lesson number 1 of our little mini quadratics unit, and it's going to be all about factoring and working with quadratics. Let's see, what color was the 4-letter? Orange. All right, so our learning target for today is I can find the GCF and factor monomials. The GCF stands for greatest common factor, and we know that monomials, and actually it's more than just monomials, but monomials are terms that just have one term to them. So we're actually going to factor monomials and other polynomials, okay? So again, on your paper, let's label it lesson 1. Today's date is 3/2. We're going to find the GCF and do a little factoring. All right, so I've got a few definitions first here. So on your paper, if you draw that line and then put those 3 terms on the left-hand side, we'll give you just 3 definitions, and then we will move into some specific examples. All right, so our first term here is GCF, greatest common factor. This is not a new term by any means, but again, we take a look at the largest, the biggest factor that 2 terms have in common. So we've done the distributive property where we've had a number outside parentheses and we've multiplied it with what's inside parentheses. Today we're doing the opposite of that. We're learning how to factor that out completely. And so we're going to look for the greatest common factor. Okay, so it's the biggest factor 2 or more terms have in common. Factored form is when you have that expression written as the product of prime terms, and you're going to have those in parentheses. So, the parentheses of x plus 2 times the quantity of 3x minus 9 as an example. So factored form, anytime you're asked to put something in factored form, your answer should actually be put inside of parentheses. The term that I don't have on here is expanded form. Expanded form would be the one where you've multiplied it all out, like we did with the distributive property. Okay, and then our third term is a prime number. A prime number is just where it can only be divided by 1 in itself, because in order for us to factor something out completely and for it to be completely simplified, we need that term to actually be prime. So those are the 3 terms that we're going to work with today. We're going to focus a lot on factored form and expanded form and learning how we can factor out that greatest common factor. Anybody need me to wait just a little bit longer with the definitions? I got you, Emma. Thank you. You want to let me know when you're all caught up. I can then we'll move into our first example. You need a little more time too, Jesus? Sam, I'm just seeing your message now about your DUR. Thank you. I'll get it taken care of sometime today. I should have time anyway. Why are all of my pens? That's fine. Sam, you're all good. All right, Emma, thank you. Jesus, are you caught up? Okay. Sam, I'm just going to start the first example. I'll make sure you have time to get caught up. So like I said, we're going to talk about finding the greatest common factor, and this is going to help us this is actually going to help us figure out how to factor. Now, for some of you, I think GCF is going to come innately to your brain, especially if you are extremely strong at multiplication and knowing your times table. So for some of you, it might be just a little bit of a struggle at first, but like everything else, the more we practice it, the better we will be. So on the left-hand side of your paper, I'd like you to write down this example. You're going to find the GCF of 12a squared b squared c and 18ab to the third. And then while you're writing that down, we're going to factor each monomial, each single term, and we're going to find out what they have in common. That's the whole idea about greatest common factor. All right. So first thing that we're going to do is we're just going to write down each term kind of side by side, and we're going to make something called factor trees. I believe you have probably done factor trees at some point in your mathematical career. All right. So the first thing that we're going to do is when you start factoring numbers, you just ask yourself, what is it that I know? What two numbers do I know that can multiply to make 12? And what two numbers do I know that can multiply to make 18? So while many of our numbers have more than one factor pair, just use any two that come to mind, any two numbers that come to mind. In the examples that I've come up with, I'm just using 2 times 6 for 12 and 2 times 9 for 18. I could have used 3 and 4 for 12, and I could have used 3 and 6 for 18. It doesn't matter which factor pair you use. Now, I'm going to focus just on that coefficient first. And then once you break it down into that first factor pair, then you ask yourself, can I break it down any further, or do I have prime numbers? I know that 6 is not prime and neither is 9. So I'm going to break those two numbers down as well into a factor pair. I know that 6 is 2 times 3, and I know that 9 is 3 times 3. Again, you ask yourselves, are 2 and 3 and 3 and 3, are they all prime? And yes, we know that 2 and 3 are prime. So we're done with that coefficient part, that numerical part of it. And so then what we're going to do is take each term and we're going to write it all. This is called prime factorization. Ignore the ovals, the red ovals, for just a moment. This is called prime factorization. So 12a squared b squared c breaks down to 2 times 2 times 3. And here's where it comes from. Here's your first 2. There's your second 2. And then there's your 3. And then we already know that a squared, this 2, means we've got 2 a's. And b squared is 2 b's. And then we've got that 1 c down here. So you're going to write it all out in a line. And then I'm going to do the same thing with my 18ab to the third. And again, where are those numbers coming from? Let me grab a different color. So here's this 2. And then each of the 3's are right here. And then I took the variables and broke it up. I've got just a, and then I've got 3 b's. Let me erase those lines so it doesn't look so crazy in there. Now, the next thing that you'll notice is I've drawn red ovals around some things. Those red ovals are what each of those lists have in common. They have a 2 in common, they've got a 3 in common, they've got an A in common, and then 2 groupings of B's. And this is how we're finding that greatest common factor. So then once I figure out what they have in common, then I'm going to take each of those terms and I'm actually going to multiply them all out together to find my greatest common factor. So then that turns into 6, because 2 times 3 is 6. I've got just the A, and then I've got B squared. Now, like I said, for some of you, if you are extremely strong at multiplication and you knew right away that 6 was that greatest factor between each of them, awesome. If multiplication isn't a strength of yours, then write it out like we did here so you can have that visual of what you see that they both have in common. So that's the first step in factoring polynomials, is you're looking for that greatest common factor. Okay, before I move on into example 2, what questions do you have about example 1? Meaning, could you explain again why? Could you tell me how come? Something along those lines. Okay, anybody need more time to write down example 1? All right, let's move on to example 2. So example 2, we are going to factor this expression, 36x squared plus 8x. So your steps, as I have listed at the top there on the right-hand side, the first thing that we're going to do is find the GCF, the greatest common factor of 36x squared and 8x. Once you find that greatest common factor, then you're going to divide it out. So this is where you're going to think this is the part that's opposite of the distributive property. The distributive property says we're going to multiply what's outside the parentheses. Well, in this case, there isn't anything outside the parentheses, so you're going to divide or take that GCF out. So these are your steps. Find the GCF, and you're going to factor or divide them out, and then you're just going to do it exactly like we do with the distributive property. So we're going to take that polynomial, that binomial, and we're going to split it up into its 2 parts, and we're going to find the greatest common factor between 36x squared and 8x. So I know that 36 can break down as 2 times 2 and 3 times 3, and that comes from the fact that 36 can start as 3 times 12, I know I can break 12 into 3 times 4, and then I can break 4 into 2 times 2. Right, so that's, here's my 2 and my 2, my 3 and my 3. Those are right here. 2 times 2 and 3 times 3. Then I also know that x squared turns into x times x. And then we know that 8 is 2 times 2 times 2. And again, if you are struggling with where did that come from, the same thing is you can take your 8 and you know that it's 2 times 4. And then I know that 4 is the same as 2 times 2. So there's where my 2 times 2 times 2 comes from. Notice we break it down into those prime numbers, and then we look to see what they have in common. They have 2 2's and 1 x in common. So 2 times 2 is 4, and then they've got that x. So just like we did in example 1, 4x is the greatest common factor for this one. Now, the directions are actually to factor. The directions aren't just to say, hey, find the greatest common factor between each of those terms. So now we're going to do the opposite of the distributive property, which says we're going to divide each term by that 4x. And this is where we're going to use those rules of exponents that we learned earlier this year. So again, the first thing that we're going to do is 36x squared divided by 4x. And then we're going to do 8x divided by 4x. So I know that 36 divided by 4 turns into 9. And we learned x squared divided by x. Remember, you subtract those exponents. So that leaves me with 9x from that term. This one simplifies to 9x. And then 8x divided by 4x just turns into 2. And then notice this 4x, our GCF, remember me saying it's the opposite of the distributive property, so that GCF comes outside the parentheses. Okay, comes outside the parentheses. So this would actually be your final answer if you were told to factor. Now, one thing I want to point out to you is that if you got to here, I know it's kind of small, but 2x times the quantity of 18x plus 4, what you really need to do is ask yourself, is there anything else that I can do to simplify? Well, in this case, there's nothing that I can divide 9 and 2 both by other than 1. But when I go down here to this little one in the corner, 2x times the quantity of 18x plus 4, both 18 and 4 can be divided by 2. Whoops. They can both be divided by 2. So I know that this isn't completely simplified. So in that case, I would factor out that additional 2, and then I would multiply it with what's outside here. So that's where that 4x comes from. So again, the big idea here is to make sure that you're pulling out that greatest common factor, and then everything inside the parentheses should be the most simplified form of what you have. And again, if you don't have it completely simplified, then you got to take a look to see what else can come out of there. Sometimes it's a variable, sometimes it's a number. You just need to use what you know about those assignments. How do you get division of 4? Right here, Jesus, in this middle part. Okay, thank you for asking. So remember when I said that factoring is the opposite of the distributive property. So earlier this year, we learned that if we had something like, I don't know, 3 times the quantity of 2x plus 4, and we wanted to distribute, remember we talked about multiplying whatever is outside the parentheses with whatever is inside. We did multiplication. Okay, factor is the opposite of that. So once you find this GCF, then you're going to divide each of those terms by it because you're trying to get the most simplified version of it. Okay, it's all about division. And then that's why it comes outside here. Like I could go in the opposite order just to double check to make sure I have it simplified correctly. And I could distribute 4x times 9x gives me 36x squared. and 4x times 2 does give me 8x. So I know that I didn't misstep with my GCF or something else in there. Okay, so it's all about the opposite of distributing. Any other questions? What other questions do we have about this example? Good question. No, I get what you're asking, Sam. And that's okay. So like I said, sometimes you're going to be able to know exactly what the GCF is. The numbers aren't going to be so crazy big that you're going to like stumble on it, especially I think we were pretty mindful with putting together the assignment. But if you know like your factor pairs of 36, right? They're 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. And then I know the factor pairs of 8 are 1 and 8 and 2 and 4. Well, the largest one that they have in common is 4. But if for some reason that doesn't come easy to you, then you either do that little factor tree like we did in example 1, or you factor out what you do know. Like maybe you knew that it was just 2, and then you look here and you're like, oh shoot, 18 and 4 are both even. I can still factor out a 2 out of each of those terms. Okay, so it's just a matter of just double checking as you do the division, the opposite of distributing, the factoring, to make sure that you've got them completely simplified. Okay. Thank you for the questions today. All right. So here's your closure on your paper. So what do you need to make sure of when finding the GCF? Write it down on your paper. What do you think you need to make sure of when finding your GCF? So one of the things that I hope you're thinking of what do you need to make sure of when you find that GCF is that if you're using a factor tree, you just need to make sure that you've got this down all the way down to prime factors, right? To make sure that you can find what they have most in common. Okay, or if you're not going to use the factor tree, then you just need to make sure that you're using the largest factor that both numbers have in common. Okay, that's like the bottom line, just making sure you have the largest number. And then when you have it factored, like we talked about in this example, is just making sure that you've got it completely factored out inside the parentheses. If this was a quiz question and you were asked to factor it and you gave me 2x times the quantity of 18x plus 4, this would probably be like a 3 out of 4 because you had the right idea with pulling out a factor. You just didn't give me the greatest common factor and get it completely simplified. All right, so your assignment for today. If you haven't done so already, you can go back into the Schoology folder and you're going to do the lesson 1 worksheet. And then you can either print it out or do it in your notebook like we have done with previous assignments. And you've got a little less than 10 minutes to get a good start on your assignment.